Guys, welcome back to my channel. It is all about studies, and today we are going to learn about playing with numbers. Playing with numbers is a chapter all about factors, multiples, LCM and HCF. Now, the very curious question that arrives in our mind when we first learn this chapter is, what is the importance of playing in numbers or LCM or HCF in our life? Well, suppose you're having a party and you have a disco ball or 3 lights in the room for the party. One light shows the color red, blue, green. One light shows the color red, blue, green too, and the other light shows the similar colors. Now, imagine you want to know at what time will all of these lights have the same color. For this, you will require LCM and HCF. But to find out at which time will they ring together, you will need to learn about LCM and HCF. So today, in this part, we will cover Session 1, which includes factors, multiples, perfect numbers, prime and composite numbers, twin prime numbers and even and odd numbers, and also the explanation of exercise 3.1. Alright. So, with the beginning of session 1, we should know what are factors. Now, suppose you have a number 12. A 12 we have as a dividend, and now we need a number which can divide 12 exactly so that the remainder will be 0. Now, to find out the divisor which will exactly divide 12, we will need to know about its factors. So, there you have the definition of factor. A factor is a number which is an exact divisor of that number. A divisor is a number which divides a number completely, or maybe a number which is used to divide a number. A divisor is that. Alright. So, next is, what is a multiple? Alright. Suppose you have a table. Now, you have a table of 8. Alright. Now, everything, 8 2s are 16, 8 3s are 24, 8 4s are 32. These are all the multiples of 8. Till infinite multiples of 8. Alright. Factors are limited. Multiples are not limited. They are infinite. You can multiply a number by billion. 8 multiply 1 billion, 8 multiply 4 billion. It can go on and on and on, but factors cannot go for on and on. 1 billion has a limited factors. It cannot be infinite. Alright? So, the numbers in the table of a number, all the numbers present in the table of a number are that number's multiple. Alright? Now, moving on, we will learn about prime number and composite number. What is a prime number? Suppose we have learned about factors, alright? Now, we have learned that factor divides a number completely. So, a prime number is a number who has only 2 factors. One obviously has all the numbers inside its table, and the number itself, because the number itself can divide it. No any other can. Neither 2, neither 3, neither 4, nothing. Only the number itself. Prime numbers are such as 5, 7, 11, 13 and so on and on. Now, there is only one even prime number in this world of mathematics, and that is the number 2 itself. The number 2 has no other prime factor other than 1 and 2. 3 is the smallest odd prime number because it has the factors 1 and 3. Alright? Now, the next is composite number. A composite number is a number which has obviously more than 2 factors, meaning the number itself can divide it, 1 can divide it, but there are even more numbers to divide it. So it is not lonely. It has some people more by its side. prime numbers are lonely. They only have themselves and the number 1. Alright. Now, let's learn about even numbers. Even numbers, you know, the numbers which are divisible by 2. Simple. Numbers which are divisible by 2. Odd numbers are numbers which are not divisible by 2. They can be either divisible by 3, by 9, but not by 2. So, they are odd numbers. Now, let's see twin prime numbers. What are twin prime numbers? Now, you already know what a prime number is. It has not more than 2 factors, only 1 and the number itself. Right? So, a twin prime number is a number which has a difference of 2. For example, 7 and 5. If we minus them, we have 2 left as the difference. Now, 11 and 13, there are prime numbers. 13 minus 11, 2. They are twin prime numbers. Alright. Now, these are all the examples listed below. I'll underline them for you. So, here are all the examples. You can read them and I'll share them in the YouTube description. Okay? So, these are the examples. Now, we are on to the exercise 3.1, which has even numbers, questions based on even numbers, prime numbers, and every other that we have learned in this video. Alright, so the first question is, which of the following is a perfect number? Now, what is a perfect number? Alright, so let me tell you, a perfect number is a number in which all of its factors, when they are all added up, they result as the twice of that number. That means that factor is the number which is obtained when that number is multiplied by 2. So, 68, no, it is not a perfect number because when we add up its factors, they do not result in the twice of that number. Next is 87, same with 87. It is not a perfect number. 24, no. 28, yes, it is a perfect number. 6 and 28 are perfect numbers. When we add up the factors of 28, they result in 56. Moving on to the next question. If A is multiple of B and C, if A is multiple of B and C is factor of B and A both, then which of the following is definitely correct? A, B and C are different natural numbers. Alright, so it is saying that A comes in the table of B and C is a factor of B and it is a factor of A both. So it's a both. Okay, so now it is asking in which of the following options the statement is definitely correct. Alright, so let's see the A option. A divided by B. That means the multiple of B, A, can be divided by B. And C divided by B. That means C, the factor of B and A, can be divided by B. B divided by A. That means the factor of A can be divided by it. C, the factor of A, can be divided by A. Here, A option is correct. You know why? Because A is a multiple of B, and since the dividend is probably bigger than the number and multiple is also bigger than the number, then the table it is in. So, here A will be divisible by B, and since it is the multiple of B, so it is definitely divisible by B. So, here A is correct. Number 3. If A and B are odd numbers, then which of the following is even? Alright. They are saying that suppose A and B are both odd. They are not divisible by 2. Alright. So, which of the following is even in the following options? Okay. So, Let's see, A plus B. Let's take an example. 3 and 5 both are odd numbers. Let's add them up. 3 plus 5 is going to result in an even number. Now let's check more options. Number B, A plus B plus 1. Alright, let's see. 3 plus 5, 8. 8 plus 1, 9. No, 9 is odd. It's not even. Next question. A, B. A, B means to multiply it. Well, if you multiply 5 and 3, it's 15. No, not possibly correct. Next, AB plus 2. Alright. So, let's see. 3 multiplied by 5, 15. 15 plus 2, 17. No, it's not correct. So, option A is correct again. Number 4. Fill in the blanks. The numbers other than dash whose only factors are 1 and the number itself are called prime numbers. Alright. So 1. It has the only number 1 to divide. So other than 1, it is neither prime, it is neither composite because it has only one factor. It is odd. It is different from any other number. It is different from prime numbers. It is different from composite numbers. 1 has only one factor. So other than 1, numbers who have only 1 and themselves are called as prime numbers. Okay, number 2. A number for which sum of all its factors is equal to dash, the number is called a perfect number. Now, I already told you perfect number is a number whose all factors, when they are added up, and the number obtained, the sum obtained of these factors is the twice of the number whose all factors are obtained, then that is a perfect number. So, if it is a multiple of that number which is divisible by 2, so here we have 2 twice. You can see twice. So our first fill in the blank option was 1 and then it was twice. So let's search. Ooh, B matches up. So B is the correct answer. Now question number 5. Read the statements carefully and state T for true and F for false. Okay, number 1. You have to tell if it's correct, if it's right, if it's wrong. If it's correct, then it is true. If it's wrong, then it's false. Okay. 6 multiple of 5 is a perfect number. What is the 6 multiple of 5? 5 multiplied by 6. It is equal to 30. 30 is not a prime number. Sum of two numbers is always odd. No, it is not. We already took an example of 5 plus 3 and it is equal to 8. So it is even. This is false too. At least one factor of 48 is always odd. One factor of 48 is always the perfect number. Let's see. Is it the perfect number? Yes, it is. Because one factor of 48 is 6. And I already told you that 6 is a perfect number. So, it is true. Alright. Wait a minute. Okay. So, now, the next one is sum of 3 even numbers is odd. Well, if you add up 2, 4 and 6. 2 plus 4 is 6. 6 plus 6 is 12. Well, it is not resulting into an odd number. So, I guess this is false too. Alright, next statement. Oh, there's no any statement left. Okay, so let's see. The first one is false. Oh, I'm so sorry. We left one, number 4. Number having more than 2 factors is a composite number. Of course, that's true. Alright, so true. This is false over here. And it is false over here, and true over here. I will erase it later. But let's see. F, F, T, T. Okay, T, T, F, F, T, T, and F. So let's search the options, and D is correct. Okay, so the correct option here is D. Next question. Match the following. So here we have matching. Okay, so we need to do this. Column A and column B. Number P. Pair of twin prime numbers. Now let's search column B and see if there is any pair of twin prime numbers. Oh, we spotted one. It is 17 and 19. Okay, so it's right here that 17 and 19 are matching with P. Okay, next, number Q. Pair of composite numbers. Pair of composite numbers. Well, it is option 1, because see, 87 is a composite number, 91 is also a composite number, so it matches with Q perfectly. Okay, now pair of perfect numbers. I already told you 28 and 6 are perfect numbers, so number 4 matches with R. And number 2 is the remaining, so it will obviously match with S. So let's see, QSPR. Alright, so you noticed one thing in these options, that Q has 3 or 2 numbers inside it. So pair of composite numbers, there are a ton of composite numbers here. One is 28 and 6 and 95 and 152. So 2 and 4 do include in Q. So let's say that option D matches our circumstances. Okay. Next, question number 7. Find the factors of the third multiple of the greatest 2-digit prime number. Oh, that's a lot. Alright. So it says that we need to find factors of the third multiple of the greatest 2-digit prime number. Alright, so to find the answer, we need to first find the greatest 2-digit prime number, and that is 97. Okay, 97 matches it. So now we have to find the third multiple of 97, and then we have to find its factors. Alright, so the third multiple of 97 is 291. Now its factors, of course. Okay, so now since we have found out the third multiple, now we need to find its factors. Alright, so its factors, well, there are two options here. 1, 3, 97, 291, 1, 17, 97 and 291. Since 291 comes in the table of 97, it obviously has to be in its factor list. Now, in the factor list, we can see that B and D don't contain 97 in its options, only A and C. So now we have to decide whether A should be the correct option or C. Okay, now A has 1, 3, 97 and 297. 3 here. Let's test if 291 is divisible by 3. If it is divisible by 3, then it should be the factor, because in our C option we don't have 3 included. So with the finding out if 3 is actually divisible by 291, we can also find out the correct option. Okay, so the divisibility rule for 3 is to add all of its digits, and the sum obtained when divided by 3 should be divisible, and if it is divisible, then the number is also divisible by 3. So when we add 2, 9, 1. So 9 plus 1, 10, 10 plus 2, 12. So 12 is divisible by 3, so the number 291 is also divisible by 3. That means option A is our correct answer. Well, next. Fill in the blanks. Every factor of a number is an dash of a number. Okay. It is an exact divisor of the number. If you remember the definition, which I'll show you here, factor. A factor of a number is an exact divisor of the number. I'll underline it here. So, what is written here? Exact divisor. So, that will also fill up our FIB. Let's move on. Okay. Now, two prime numbers whose difference is dash are called twin prime numbers. So now twin prime numbers are the numbers whose difference is 2. They are prime numbers. Okay. Just wait. Okay. So here 2 is our answer. Numbers having more than 2 factors are called composite numbers. You remember the definition, right? Okay. So here A is our correct answer again, because exact divisor the first answer, 2 the next answer, and composite are next answer. Okay. Now the next question is, express 173 as the sum of 3 odd prime numbers. Alright, so we need to show that 173 is the sum of 3 odd prime numbers. Alright, so if we add option number C, 71 plus 71 plus 31, we will obtain the sum 173. So we will receive it. We will receive the number 173. So it is also expressed as the sum of 3 odd prime numbers. Alright, moving on to the next question, number 10. It is a match the following again. So column A, factor of 512. Here, factor of 512. Well, it is 128. I did some calculation, and after dividing 128 by 512, it is divisible. So it is a factor of 512. Now, multiple of 512, how to find out? Well, since 5 and 5 add up to 10, 512 when added to it, we will receive 1,000. So here we have 1,000 right here, 1,536. So you got the answer. Now, factor of 343, it would be 49. Alright. And now multiple of 343, if we add 343 and 343, the twice of 343, it would be 686. So now if we match up, P equals to 2, okay, Q equals to 4, and R equals to 1, and S equals to 3, okay. So we have our option right here. It is option number B. Now 11. Find the sum of first 5 multiples of the smallest composite number. So now we have to find the sum of the first 5 multiples of the smallest composite number. So we have to find the smallest composite number, which is 4. And now the first 5 multiples, which are 4, 8, 12, 16 and 20. Now if we add them up, we will receive the number 60. So C is our option. 12. Write the two pairs of prime numbers less than 20 whose sum is divisible by 10. Okay. So now the two pairs of prime numbers which are less than 20, they should be less than 20, and their sum, when they are added, it should be divisible by 10. Okay, so now let's add. I've added them all, and option D, when we add 3 plus 7, 10, 7 plus 13, 20, and then 20 plus 10, we receive 30, which is divisible by 10. Alright, question number 13. Write all the 2-digit prime numbers ending with 7. Okay, so in question number 13, option B is correct because there are all the prime numbers present with the ones place value with 7 filled in it. Okay, 17, 37, 47, 67 and 97. Okay, now number 14, it is a true and false question. So all prime numbers are odd. No, that is false, of course, because 2 is an even prime number. 1 is neither prime nor composite. Well, it's true. So 1 is neither prime neither composite because it has only one factor. So the first one is of course false and the second one is true. Let me write it down. First one false and second one true. The sum of two prime numbers is always even. Let's add them up. 5 and 7, 12. 5 plus 3, 8. So this is true also. If an even number is divided by 2, then the remainder is always odd. No, that is not true. Because if we divide a number by 2, it is obviously divisible by it. Okay. If an odd number is multiplied by any even number, the product is even. Okay, so if an odd number is multiplied by an even number, suppose 5 multiplied by 2, then their product is always even. Let's try 5 to 10. Okay, 5 and 4, 20. Well, yes, it is even. Okay, so we have it right here. False, true. Okay, true, false, true, true, and then false, and then true again. So you can search for the option yourself. Thank you for watching my video. We'll meet in the next session, session 2, which will be divisibility rules, and I will explain them and tell them why they are important.